Hi there, I am doing a bench test of this very interesting and very well built Miranovich solar powered floodlight. It has state of charge LED indicators. Now I'm charging this not through its, this is what's called a bench test. So I'm charging this through a programmable power supply. And I tested the solar panel first. I found out that the solar panel gives off approximately 5.6 volts as its mean average. So I'm going to stop this for a minute so I can see what we're doing. Okay. Let's stop this. Okay, there's the halt. I'm charging it at 5.69 volts DC, which is simulating the average of its solar panel. And then to see what kind of internal resistance the battery gives, I'm using this function, which is the constant current setting, to see how many watts the battery, which is supposed to be, it's labeled as LiFePO4, which is a great battery choice in my opinion. So, sorry, I'll escape from that. So, this is its first charge, so it may change over time, but right now the batteries are saturating at 2.24 watts only, despite the solar panel is labeled as 8 watts maximum. But I found that, see, it says constant current. If I change that to, let's build it up to, let's say, this amount here, you see at 3 watts, the constant current signage no longer appears. So this means that the power supply is delivering more energy than the batteries can absorb. So it's not, so that tells us that this battery pack's internal resistance will not allow much more than, say, 2.5 watts, despite the size of the solar panel. Otherwise, this has incredible connectors, O-ring, and they're using oxygen-free connectors, and it's got an O-ring, so very unusual to see it. And look at the strain relief on that. That is like magnificent strain relief on and this type of cable that they use, it is really, really solid. It's like medical grade power cables. Congratulations to whoever Miranovich is. He is a very serious builder, because this is steel. So he designed this. Mr. Miranovich should be congratulated. And especially you've got the state of charge indicator. So the only thing I would comment on is that the way the other solar panel builders that I have. So here's an example. This is a solar panel from another solar light that I have from China, which is very expensive. It's about $150 for one. So this is the high-class group's this is like $160 roughly from China, and it is a 15 watt LED from the high. Now the difference between Miranovich's and this one is that, you see, this is only a 7.4 volts. So they have two two lithium batteries in series. However, they're charging it with a 14-volt solar panel, 12-volt nominal here, but 12-volt, 14-volt actual. So the Chinese solar panels, they have realized that on a cloudy day, you're better off with a higher voltage solar panel, and then use the electronics to bring it down to use BMS electronics, battery management system electronics, to bring it down to the volts required. That way, on a cloudy day, this unit is still charging even on a very, very cloudy day. I was very surprised that it can actually now pick up energy from a very cloudy day in Vancouver. Most of the new Chinese solar powered lights are built this way. They have solar panels that are higher voltage than is required, and then the voltage is brought down to the required DC voltage by smart electronics. Now let's contrast that to Mr. Nick Miranovich's solar panel. Here's the specs, and I have a couple of them. So it's 5 volts maximum. However, I've found it to be 5.6 volts actually maximum. Open circuit voltage is 6 volts. This design, in my opinion and experience, would not be the most suitable for a cloudy city in the winter like Vancouver, Canada. So, yeah, the high voltage solar panel are superior in this latitude in this part of North America. But if you were living in Florida or somewhere where it's sunny, Nick Miranovich's solar panel and electronic design would be excellent. Over and out.